Hey kids, it's time for our AP Stats class to take a look at lesson 4.2, day 2. Would you fall for that is what it's called. And this one starts off with a video that you're supposed to watch. And I'll paraphrase the video a little bit for you. It's only about 3 minutes long. The video is dealing with something called the placebo effect. It's from ABC. They're promoting a TV show that they have called, what do they call that? Would you fall for that? I think that's what it was called. So anyway, I watched a video, and here's what I got from it. They've got these people at, looks like a county fair or something, and they have people hit the hammer and it shoots up to a bell. I have no idea what you call those things, but you probably have seen them before. You take a hammer and you smack it on the ground, and it shoots up an object up to ring a bell. So anyway, they've got one of those kind of things going on, and they're trying to hawk people to come and to do that. And what they do is the people will do it, and they see what their score is, and then the people from the TV show offer them supposedly a power drink, and it's actually nothing more than carbonated water. So it's like a placebo. So they get this carbonated water and they give it to the contestants, and then they build their confidence and say, oh, you know, this has instant effect. You're going to be so much stronger now. And then they have them try it again, and they see if when they hit the hammer down with the bell actually goes, or it goes closer to the bell, or even rings the bell. And there's one person in particular on the video that they have, one contestant, and he had a 7. And then when he slammed it down after getting his placebo, his carbonated drink, which they had changed labels and put their own name on it, all of a sudden he got a 10. He had hit the jackpot. So what they're trying to imply is the placebo effect, and they're using it to promote some TV show. But let's answer the questions in that context so that you can understand the math and the concepts behind this. So it starts out with, would you fall for the placebo effect? Watch the video. Okay, I'm going to send you a link on the video in an email. And if you don't get it, don't worry, you're not missing much. It's mostly promotional for a show. They're just trying to get that situation I described. And he's the only guy that they showed. They didn't show any other contestants. But that says, what do you think, or why do you think the people in the video got stronger? And there was actually only one that they showed. And the implication is that the placebo effect took place, that this man thought he should be stronger, so he tried harder, perhaps. In addition to the would you fall for it, or would you fall for that carbonated water, they called it whiffed, using the abbreviation for the name of their show. They also gave him a lot of verbal encouragement. So it wasn't just the placebo. They also told him, oh, you're going to be so much stronger. They had him stretch a little bit. Then they talked him up and built up his confidence, and perhaps that may have increased it too. They did not show any of the other contestants. I'm guessing that in some cases they showed no strength increase at all. Of course, why would they put them on a TV show? They probably put the ones on that showed the placebo effect in action. So that's what happened for that. And that's how you'd answer the first question in our notes. Then it says, similar to the video, Mrs. Gallus wants to use a beverage to test the effect that caffeine can have on heart rate. Here is an initial plan. She wants to measure the initial pulse rate, give each student some caffeine in the form of Coca-Cola, wait for a specified amount of time, measure the final pulse rate after the caffeine has been consumed, and I'm guessing they're going to wait a certain period of time, and compare the final and initial rates. By the way, this sentence uses the word effect with an A. There's also effect with an E. For the life of me, I haven't been able to differentiate the difference when I'm writing or reading all that much. So I may write in the notes the wrong effect. Just write it in your notes with the correct spelling. So here's the situation. Now, number 2, what are some problems with this plan? What other variables will be sources of variability in pulse rates? Some problems with this plan, this is number 2 now. Some problems with this plan are or include there's no control group to compare to. They're just giving this cola to everybody. So there's no control group. A control group would be somebody that didn't take the caffeine. Maybe they took the non-caffeinated soda. Number 2, Coca-Cola is not just made of caffeine. There's other stuff in there too. And when they test, hey, if the pulse rate goes up, maybe it has something to do with the sugar content or something else. And number 3 would be, at least what I put was, there could be a placebo effect because people know they're getting caffeine. It's like, okay, here's your caffeine. You know what it's supposed to do to you. Now, do you see the effects? Does that go? I don't know if you can control your own pulse rate, though. I think that's involuntary. But anyway, that's the concept there, my friends. So number 3 says, go back to your list in number 2 and propose a solution for each problem. Okay, the first situation, maybe you could add a control group. Put a group that doesn't take the caffeine, they take the non-caffeine. Then you could, number 2, maybe you could control the other variables. Maybe you could take the sugar out, or maybe you could already know what impact the sugar has and then see if the caffeine has more, something like that. Trying to control the other variables, because in an experiment, you don't really want those confounding variables to be in there if you can avoid it. Sometimes you can't avoid it. And a third one would be to use a single blind experiment. Don't tell the person taking the Coca-Cola whether or not they have the caffeine version or the non-caffeine, or even a double blind where the experimenter doesn't know either until after the test is taken. All right, so here's a design. They want us to design an experiment. So that's what we did for you. So let's say you select 100 students randomly. Then you split those 100 students into 2 groups. So you got 50 on one side and 50 on the other. One of those groups is going to get the regular Coke. The other group's going to get the caffeine-free Coke. When they're done, we're going to compare and see if they indeed have a difference or not. And then we would try to figure out if it's statistically different. So anyway, this is a flow chart of the experiment, starting with 100 students, and you compare the results at the end. Okay, so let's talk about the check for understanding, and then we'll go through these big ideas. I don't know about you guys, but these big ideas on these worksheets are not always providing me enough space. Today it did in this section, but sometimes it doesn't. So we may have to use the margin or even maybe other parts of the paper. But anyway, let's take a look at that later. So here's a situation with checking for understanding. Many utility companies have introduced programs to encourage energy consumption among their customers. An electric company considers placing small digital displays in households to show current electricity use and what the cost would be if this use continued for 1 month. So they have a time limit on it. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from their outside meter. Would this method work almost as well? The company decides to conduct an experiment using 60 households to compare these 2 approaches, the display and the chart, with a group of customers who receive information about energy consumption but no help in monitoring electricity use. So basically, guys, there's 3 groups we're talking about here. One is going to get this display, one's going to get the chart, and one's going to get neither of those. Okay, so question A, explain why it is important to have a control group that didn't get the display or the chart. Well, the control group allows us to show how much electricity customers would normally use if they weren't affected by the things that we're experimenting for. So it provides us the baseline data. Part B, describe how to randomly assign the treatments to the 60 households. Okay, well, you could randomly generate 3 groups. Now you could take 60 little note cards and put down 60 numbers and mix them all up. and then say, okay, here's our first group. This is going to be the group A, say, that's going to get the display. Okay, fire down, you pick your 20 cards out, there's your group. Then you take your 20 cards, the next 20 that you select, put them in a stack, and that's going to be the people that get the chart. And then the third group of 20, you got your leftover 20 cards, and that'd be the people that get nothing. So that's one way to do it. You can also use a random number generator on your calculator or on that website that I showed you, where you tell them how many you want in the group, and then you do that. And so you could do that also. But the 20 note card thing is probably what we would do in class if we were doing this one non-virtually. So let's see. C says, what's the purpose of randomly assigning treatments? The purpose is to create roughly equivalent groups. Okay, we were trying to balance all the variables. And the only way we really know how to do this is to randomly select and hope that we get a good cross-section of different types of situations. We might not. We might, just by the sense of randomness, we might get a whole bunch of people that either use a lot or use a little energy as it is. But the concept of randomness is we're going to get a little bit of everything. And so that balances out the other variables. And then, my friends, at the end, we have our chart. Create an outline showing a completely randomized design for the experiment. So we started with 60 households. We did the random assignment. We divided them into 3 groups. One group treatment was the display. One group treatment was the chart. Another group treatment was neither. And then we compared electricity usage at the end. And that's it. We want to thank, as always, Stats Medic, who came up with these note pages for us that coincide with our textbook. They do a great job. And so do you. We are very proud of you. You guys are doing fabulous. Until next time, it's your math teacher, Mr. Murphy, signing off from Oshkosh North High School. Stay awesome, Spartans.